Hello, my name is Megan, and I will be sharing with you today what an EEG machine is and the physics behind it. So what is an EEG? An EEG, or an electroencephalogram, is a neuroimaging method based on the theory of volume conduction of ionic current through non-empty extracellular space. This theory helps explain the process of electrical signals from neurons being able to travel through fluid-filled extracellular space, or the space between tissues and organs throughout the body. So, according to this theory, an EEG is a machine that can record electrical signals traveling through the fluid-filled extracellular space in the brain, or, in simpler terms, able to record electrical brain activity. This is done with electrodes attached to the subject's scalp, if done non-invasively, or subdurally or on the cortex itself, if done invasively. Overall, an EEG is a neuroimaging process used to evaluate electrical brain activity and, therefore, dynamic cerebral functioning. What is an EEG used for? An EEG machine is utilized in the medical field to identify the electrical brain activity of patients with suspected seizures, epilepsy, brain tumors, stroke, and other neurological disorders. It may also be used in settings like monitoring the use of anesthesia during surgeries, among others. By serving as a method to detect abnormalities in a patient's brain, the patient may be properly treated for the neurological disorder they may have. Revolutionary work is also being done to further analyze how an EEG can more easily identify neurological disorders, like depression and Alzheimer's disease, by integrating neurobiological and electrophysiological data into the process to enhance the machine's sensitivity and specificity. The use of biomarkers, improved machine learning techniques, and other integrations highlight the possibility of healthcare providers being able to be more accurate with their diagnoses and predictions of neurological disorders in the near future. So what is an EEG machine made out of? The physical makeup of an EEG machine includes between 16 and 25 electrodes, which are small metal discs with thin wires in a computer screen or paper for the evaluated information to appear on. The electrodes are either attached to the patient's head using adhesive or as a cap. It is essential for them to be securely attached to the patient's head because they are the objects that detect the electrical brain activity and send the information through the wires to the computer screen or needle that draws the information onto the paper. What are the physics behind an EEG? To get more into the nitty-gritty of what occurs within an EEG machine, when the metal discs of the electrodes are attached to the brain, they can detect the action potentials of neurons in the brain since the electrodes are electrically conductive. These action potentials are essentially where electrical brain activity is generated from, since it is an electrical event that signals a neuron as active and results in the release of a neurotransmitter, or the biological molecule in the body that is responsible for initiating thoughts, movements, and other physical or mental activity related to the brain and body. The release of the neurotransmitter is how the neurons can communicate and send these signals to one another. So, a healthcare professional will be looking at the health of these communication lines, especially when there may be a neurological mystery involved with the patient. The electrical activity according to this chemical reaction is when the EEG machine reads. It records explicitly the difference in voltage between different electrodes, a process called differential amplification. The different electrodes are called an active electrode, which is the one actively exploring the brain's electrical activity, and the other is the reference electrode, which is relatively inactive and serves as the reference point for environmental noise. The EEG machine finds the difference between these electrodes and amplifies the signal about 10,000 times, a process called amplification. This signal is then digitalized and recorded onto the EEG machine screen. Then, this information is graphed as voltage over time by using physio-mathematical methods like Fourier and wavelet transforms. In this case, the EEG machine is also considered to be a galvanometer, or an instrument that can detect and measure small electric currents. It does this by observing the deflection of a copper hoop or coil of wire and an attached needle that rotates in a magnetic field when the current flows through. And based on the speed of rotation, different brain wavelengths and, therefore, electrical signals can be measured. The machine then traces these electrical signals onto graph paper by moving beneath them and drawing the waveforms with an attached pen. Furthermore, the resulting graph on either the EEG machine's screen monitor or the attached paper graph can reveal different brain functions according to changes in time and space in solving cognitive tasks and motor and perception abilities given to the patient to do by the healthcare professional. The specific types of brain waves that are more commonly measured by an EEG are delta waves, theta waves, alpha waves, and beta waves. These are measured in hertz, Hz, or cycles per second on the graph. These different waveforms have also been used to point out different characteristics of a person. For instance, delta waves have a frequency of less than 4 cycles per second, or less than 4 Hz, and are seen in stages 3 and 4 of the sleep cycle. If they are seen during wakefulness, it may be a sign of encephalopathies or underlying lesions in the brain. Theta waves oscillate with a range of 4 to 8 cycles per second, or 4 to 8 Hz, and are characteristic of when someone is being creative or in REM sleep. Alpha waves oscillate with a range of 8 to 12 cycles per second, or 8 to 12 Hz, and are characteristic of showing up in the second year of life and are associated with relaxed alertness in adults. Beta waves oscillate with a range of 12 to 30 cycles per second, or 12 to 30 Hz, and are mostly associated with active or anxious thinking and active concentration. The specific oscillation values for all the before-mentioned brain wavelength types vary across sources, but more than a few sources agree on the ones mentioned before. When dealing with the measurement of electrical signals in the brain, though, the specific values are undoubtedly prone to vary since it is hard to place a concrete value on something more abstract. And finally, once the specific wavelengths read by the EEG machine have appeared on the monitor or the attached paper graph, a trained physician can interpret the resulting waveforms on the graph to determine any abnormalities in the brain. This can then be utilized to help diagnose a patient and get them to treatment as soon as possible if it is needed. All in all, that is the end of my educational video about what an EEG machine is, and I hope you enjoyed.